Okay, so now that we know what inverse operations are, we're going to show how they're applied in algebra. Now, we've done these kind of questions. X minus 8 equals 23. Now, you can solve this equation just by giving the answer because it's easy. This one's an easy one. But to show how an inverse operation will give you the answer, you see that 8 is being subtracted, and the opposite of subtracting is adding. So we add 8, and we do the opposite to both sides. You see the opposite operation is in red here. Minus 8 plus 8 equals 0, and 23 plus 8 gives you the answer, 31. By doing the opposite to both sides, we isolate the x and solve the equation. So right here, see this plus 11? If we take away 11 from both sides, the 11 will go away from this side, and minus 7 minus 11 is minus 18. Now we've isolated the x. X is getting multiplied by 3, and the opposite operation is to divide by 3. Opposite operations are the way we solve equations. And when equations get complex, you just have to understand this idea. So the opposite of minusing is adding, the opposite of multiplying is dividing, the opposite of adding is subtracting. Let's take a look at this question. Well, it says x to the second power, x squared, is divided by 7 equals 7. Well, the opposite of dividing by 7 is to multiply by 7. So we do that to both sides. But multiplying by 7 and dividing 7, they cancel right there, those operations. And 7 times 7 is 49. Now we've got x squared by itself. We've isolated it. But now we've got to do the opposite. The opposite of squaring is square rooting. It reverses that operation. In fact, it kind of cancels it, so we're just left with x. Instead of x squared, it turns into x. But the square root of 49 means, what do you multiply by itself to equal 49? It's 7. But there's two answers that would make this equation true, positive 7 and negative 7. So just look at these examples and think about opposite operations, because it's so important later on in all solving equations. And here's 4 questions pretty similar to the ones that we've done that you'll be able to try yourself. So good luck with that.